Hello everyone, this is Gregory from ChemCore. This is the first explainer video uploaded to my channel. This will follow the atomic structure video from the organic chemistry course. If you don't know where this worksheet is, this is completely free. It is in the description of this video as well as in the description of the atomic structure video, the actual topic video. This video is, most of my explainer, the topic videos are more short length, or they're 5 to 10 minutes long, just explaining the topic and getting right to the point. But these explainer worksheet videos are going to be a little bit longer, mostly uncut, unedited, just me just talking through the worksheet as I would do it in a real life scenario. If you don't feel like watching this whole video, there is an answer key available in the description as well. Just look through that, and if you feel like you're doing good with the material, don't bother watching this video. Continue to the next. If you're still watching this, I'm assuming that you want some help, and so let's work through this worksheet together. I'm going to be writing on this worksheet in red. My handwriting isn't too great, but hopefully it will be understandable as I'm talking at the same time. According to my video, the atomic number is the upper number in our, let me redo that. It's our upper number in the elemental notation. So 8 is our atomic number. Our mass number is the lower number in the elemental notation. This is an example of the elemental notation that I was talking about during the atomic structure video. And the mass number is therefore 16. The charge of the element alone, well, what does that mean? Oxygen is in group 6, which means it is 2 removed from the noble gases. My handwriting is a little jumbly. Let me fix that. It's 2 removed from the noble gas group, group 8, which means it's probably going to have a charge of -2 when alone. And this is true. We'll be able to explain this later on. If you didn't really understand this, maybe go back to your general chemistry course notes. This should be a pretty clear concept when doing this worksheet. Let's work through some of these examples. I'm going to pull up the periodic table on my screen, but you should have this available to you when you're doing these problems. Sodium, Na, according to your periodic table, it's in group 1 and has an atomic number of 11. But to be honest, we didn't really even need that. What do I mean I didn't even need that? Well, the problem is giving us that the number of protons is 11. And we know that the atomic number is directly the same number as the number of protons. So I don't even have to look at my periodic table. And we're going to try the rest. Some of these problems, we will need the periodic table later on. But most of these problems, we actually will not. And so let's try to work with them without the periodic table from now on. And so we can actually derive the atomic number just from the number of protons that are given to us. We also don't need the periodic table for the mass number. How do I know that? Well, the mass number is defined as the number of protons plus the number of neutrons. And if the neutrons are given to us, well, we just add the 2. And that means that the mass number is 23. The number of electrons, well, you might be confused, but don't be. The symbol given to us doesn't say a charge. There's no charge given. This has a charge of 0, which means that the number of electrons must equal the number of protons, or 11. Excellent. K, potassium. Once again, let's try to do this without our periodic table. I don't see a charge on the symbol. Actually, none of these problems have a charge on the symbol. And so the number of electrons must equal the number of protons. The number of protons must be 19. And that means that our atomic number must also be 19. Why? Because our atomic number is the number of protons. Our number of neutrons, how do we get that? Do you need the periodic table? No, not at all. The number of neutrons is the mass number minus the atomic number. In other words, the mass number is just the number of protons plus the number of neutrons. And if the atomic number is the number of neutrons, well, we just subtract. And we get 20 for the number of neutrons. This one will require the periodic table, just so we can figure out what symbol, what element this really is. I don't expect anybody to have memorized the periodic table. I sure haven't. The number of protons, what we can derive, though, is our atomic number. Once again, our atomic number is the number of protons in the molecule. And according to our periodic table, looking, is strontium. If you don't know how I got this, I literally have a periodic table on my other screen. You can't see it, but I suggest you have one next to you for probably the next couple of videos and the next couple of worksheets. The mass number, well, I already have my periodic table pulled up, but I really don't need it. Our mass number, once again, is the number of protons plus the number of neutrons. The number of neutrons for us was given, which means we have 88 as our mass number. Number of electrons, well, strontium is not charged, and so the number of electrons must equal the number of protons, which should be 38. Fluorine, I do not need the periodic table for this. F is fluorine. The number of electrons is given to us, 9. And fluorine, in this example, is uncharged. It has a neutral charge, which means that the number of protons must be equal to the number of electrons, or 9. Let me draw that nicely. My 9s often look like 5s. In other words, the number of protons is directly equal to our atomic number, which is 9 as well. Easy peasy. The mass number is our number of protons plus the number of neutrons, or you could think of it as the atomic number plus the number of neutrons, which means that we have an atomic mass number of 19. Excellent. Our atomic number in the next problem was 20. Let's try to figure out the rest of these values and then find the identity of the element from our periodic table. The atomic number is 20, which means the number of protons in our molecule must also be 20. The number of neutrons, how do we find that? Well, once again, the mass number is the atomic number plus the number of neutrons. Or in other words, you can just think of the mass number. The mass number is the number of protons plus the number of neutrons. And so we can subtract 40 minus 20 to get 20 neutrons. And according to our periodic table, the atomic number of 20 is the element calcium. Ca for calcium. Awesome. Super important for our bodies. The next problem, atomic number of 50. Let's try to generate as much information as possible and then refer to our periodic table. The atomic number of 50 should have 50 protons. Excellent. Our mass number should be, well, just the atomic number plus the number of neutrons. So let me pull out a little calculator. Not too good at math. 50 plus 69, 119. 119. And using our periodic table, we can determine that 50 is the element tin, or the symbol for it is Sn. Excellent. Iodine, our next symbol, has an atomic number of 53. In other words, the number of protons is also 53. Iodine in this example is uncharged, which means the number of electrons must equal the number of protons, or in other words, 53. The number of neutrons, well, it's the mass number minus the atomic number will generate the number of neutrons. And once again, I'm just doing this really quickly on my calculator. It's going to be 74. I'll do that. 74. Excellent. The next problem, sulfur, is a pretty interesting example. None of the information is given to us, and so that means that we probably do really need to use our periodic table. According to our periodic table, sulfur has an atomic number of 16 and a mass number of 32, which means from the atomic number, we can directly generate the number of protons, which is 16. And the number of electrons, well, sulfur is uncharged in this example, which means that the number of electrons must equal the number of protons, which is 16. The number of neutrons is, well, the mass number minus the atomic number. Undo that. The number of, once again, the mass number minus the atomic number, which is 16. The next problem, chlorine. Once again, not much information given to us. According to the periodic table, chlorine has a atomic number of 17 and a mass number of 35. 35. 35, which means that the number of protons must be 17. The number of electrons, well, the example is uncharged, which means the number of protons must equal the number of electrons. In other words, also 17. The number of neutrons is the mass number minus the atomic number, which is 18. 18 neutrons. Excellent. Excellent. 12 is the only value given to us in the next problem. And according to the periodic table, 12 is magnesium, or the symbol for it is Mg. Mg. Excellent. The mass number for magnesium, according to the periodic table, we also should get that, is 24. Is 24. Is 24, which means that the number of protons is the exact atomic number, which is 12. The number of electrons is equal to the number of protons, which is 12. And the number of neutrons is the mass number minus the atomic number, which should also be 12. Excellent. The next problem, all we're given is the number of protons, but getting the number of protons, we can exactly get the atomic number, which is 15. And according to the periodic table, 15 is phosphorus, or the symbol P. All right. And according to the periodic table, the mass number of phosphorus is 31. 31. And so the number of neutrons is the mass number minus the atomic number, which is 16. Excellent. And the number of electrons, well, phosphorus in this example is uncharged. Well, just take my word for it, that is uncharged. And so the number of electrons is also 15. Excellent. Let me fix that a little bit. Okay. The next problem, also the only thing given to us is 35. And so the atomic number is also 35. And according to our periodic table, 35 is bromine. Bromine with the symbol Br, which has a mass number of 80. 80, according to the periodic table. Make that nicer. 80. And so the number of electrons must equal the number of protons. In other words, also 35. Our last and final problem, neon, a noble gas, has an atomic number of 10 and a mass number of 20. And so the number of protons is once again the exact atomic number, which is 10. The number of electrons is, well, neon is uncharged, which means the number of electrons must equal the number of protons, which is 10. And the number of neutrons is the mass number minus the atomic number, which is also 10. Awesome. Let's continue throughout our sheet. Identify the number of protons, neutrons, and electrons for each of the following isotopes. I have a couple first problems, isotopes for carbon. And so let's figure out how many protons we should have for the first example, and then maybe evaluate what we can do from there. Let me redraw that P. P stands for protons, just for the future of this video. The number of protons we can derive directly from the periodic table, and the atomic number of carbon is 6. Remember that in isotopes, the number of protons do not change. In other words, the atomic number does not change. And so if we have all of these isotopes of carbon, will the number of protons change? It should not. And so we can actually just find the number of protons for each of them. In addition, none of these isotopes are charged, which means that the number of electrons must always equal the number of protons. So for each of these, the number of electrons is also 6. Let me write that down. What about neutrons? Well, neutrons is what changes within isotopes. It is the mass number, which is shown here, minus the number of protons. And so we can just subtract that really quick. 12 minus 6 is 6, while 13 minus 6 is 7, and 14 minus 6 is 8. And so as you can see, as we change isotopes, the only thing that we're changing is neutrons. Why? Because the only thing that we change is the mass number. The number of protons remains the same. the next three problems. We have two examples of oxygen as isotopes. Oxygen, according to our periodic table, has an atomic number of 8. And so for the first example, we should have 8. 8 as the number of protons. Why? Because the atomic number is 8. And if the number of protons does not change within isotopes, or the atomic number does not change within isotopes, well, for the next example, we should also have 8 protons. And both of these examples are uncharged, which means that the number of electrons for both of these must also be 8. However, the number of neutrons does vary between isotopes. It is the mass number minus the number of protons. So 16 minus 8 is 8, while 17 minus 8 is 9. The next example, and the final example, phosphorus. Well, according to our periodic table, phosphorus has an atomic number of 15, which means that it has 15 protons. And it is uncharged in this example, which means it must also have 15 electrons. And the number of neutrons is the mass number minus the number of protons, which is, can't do math, 18 neutrons. 18 neutrons. And that is the last problem for this worksheet. Once again, the blank answer, the blank worksheet should be in this description, as well as in the original video for the atomic structure in the organic chemistry course. And the answer key, the full answer key, kind of cleaned up more than this, should be in the description of this video and in the description of the atomic structure video. All right, guys, keep up with the Orgo studying, and I hope you enjoyed this explainer videos. There will be explainer videos for every single worksheet, completely free for this entire channel and for the entire organic chemistry course. Peace, guys.